The CARMA program is propelling the research and development of cooperative driving automation, or CDA, in the transportation space. The program uses open source software, or OSS, and an agile approach to test and refine CDA features that involve infrastructure, properly equipped automated vehicles, and other road users. CARMA platform runs on a computer within a vehicle and enables Society of Automotive Engineers Automated Driving Systems Level 3 research capabilities to enhance research on cooperative driving tactics such as speed harmonization, cooperative lane change and merge, and vehicle platooning. CARMA platform is available on GitHub, a software development platform. Currently, CARMA platform is integrated into the Federal Highway Administration's research fleet of passenger vehicles and heavy vehicles, and soon-to-be fleet of scaled-down model vehicles. This video takes a closer look at the CARMA passenger vehicles. The Federal Highway Administration's fleet of CARMA passenger vehicles includes 2 SUVs, 1 blue and 1 silver, 2 minivans, and 1 mid-size sedan. Each CARMA passenger vehicle contains computer and controller equipment, communications equipment, and a variety of sensors. The following computer and controller equipment are included in each passenger vehicle: a Crystal RS252S13 rugged 2U server for onboard data storage, a Novatel PowerPack 7D Global Navigation Satellite System, or GNS, with IMU IGM S1 Inertial Measurement Unit, or IMU, for stable and consistent 3D navigation. Sound-off signal and force light bars mounted in the front and rear windows, which flash a variety of patterns to indicate the status of the vehicle or control system to external observers. An autonomous stuff Spectra computer with NVIDIA RTX 2080 graphics processing unit, or GPU, running Ubuntu version 16 for information collection and communication and vehicle automation and cooperation logic. The drive-by-wire controller included varies by vehicle. The minivans include a New Eagle by-wire controller. Each SUV includes an autonomous stuff PackMod by-wire controller, and the midsize sedan includes a DataSpeed by-wire controller. The following communications equipment are included in each passenger vehicle: the Coda MK5 onboard unit, or OBU, for dedicated short-range communication, or DSRC. A Cradlepoint COR IBR 900 mobile router for Wi-Fi and 4G LTE connectivity. The following sensors are included in each passenger vehicle: 2 Allied Vision Mako G319C cameras, a Delphi ESR 2.5 sensor for forward-looking, mid, and long-range detection in front of the vehicle, a Mobileye 630 camera, a Velodyne UltraPuck VLP32C for localization and object detection, 2 pairs of Delphi SRR2 sensors mounted in the front and rear sides of each SUV and each minivan, 4 Delphi SRR2 sensors mounted on each corner of the midsize sedan, an Ergoneers eye-tracking vehicle testing kit in the silver SUV. Also accompanying the CARMA passenger vehicles are several pieces of networking and power equipment which will not be covered in detail here. The CARMA program was developed to engage with the industry in developing and advancing CDA functionality with the end goal of transforming transportation through automated vehicles working together. Through this critical work, the Federal Highway Administration aims to harness CDA concepts to improve the safety, mobility, and overall performance of the transportation system. For more information on the CARMA program, please visit the Federal Highway Administration website or email karma@dot.gov.